This is our last keynote presentation. It's not really a keynote. It's going to be a roundtable, more of a casual discussion. It's titled NAND Flash and its Impact on the World. So we have 4 technologists who are going to be here. Paul Saffo will be leading the discussion. Paul Saffo is a good friend of mine. He teaches at Stanford University, and he's a futurist. And I'm happy to welcome him and our others to the stage.
Come on up, guys. Good. Thank you, sir. Afternoon. Doug, we're going to put you right there. And Santosh, you're next to him. And Luca is off to the right. And Doug has brought some things to show, by the way. Good. So welcome to this session. I'm Paul Saffo. You can clear my bio off that screen. You all know how to read in the manual. But anyway, so here's what we're going to do. We're looking at taking the 35-year mark, looking back, looking forward. They're going to go all the way out 35. This will be Luca's second pass since you gave us the 35-year look on day one. And just to reintroduce everybody, so Luca over here, Senior Vice President of Technology and Manufacturing at Western Digital. And a little detail that's not in the bio is he's a maniac triathlete and self-describes it as, in my spare time, I like to punish myself by running triathlons, or running, swimming, and biking triathlons. Next to Doug is Santosh Kumar. Santosh is Director of NAND Technology, Technical Marketing at SK Hynix. And he was a little less forthcoming about his personal life, but I did find that it turned out that Flash saved his marriage because he had to have all the early products, and his spouse was really thrilled when he came in with the early digital cameras. So it is proof that Flash can help your social life. And last but not least, right next to me is Doug Wong. He's the Senior Applications Engineer at Kioxia, and he's been in the business 35 years. Coincidence, 35 years, Flash. I remember that, I think it was Rodney Dangerfield once said he'd been in TV so long, he'd been in it since it was radio. And so Doug is really the eminence grise here, who's been in a long time. And he's a California kid, raised out in Oxnard, but he was, unlike me, he was a serious student and didn't surf. So let's dive into it, gentlemen. And by the way, audience participation is encouraged, even though they put these bright lights in our eyes so we can't see any of you. But Brian's around here somewhere. Brian, where are you? Hey, Brian, you supposed to be out here with a microphone? Good. Well, Brian will show up shortly, but...
I am here. I am here.
Is he?
Where?
To your right.
Oh, there you go.
Yeah, now come in closer, and Brian may actually slip in an occasional comment on all of this stuff too. But so first area I want to explore. We've got 42 minutes left. Think about the applications over the last 35 years that were made possible by Flash. What were the big ones? Of course, the first one that came to mind for me was, Flash, digital cameras. And digital cameras, if you think about it, so who here is old enough to remember emulsion film? Good. Yeah, I teach at Stanford, and so like anything that didn't happen at least more than 2 years ago, the students don't know what it is. But emulsion...
We used to have a class called Alternative Processes, which was old processes, and that's what film is now.
That's right, yeah. Well, so to me, the revolution was with digital cameras enabled by Flash. It meant you could go on vacation and you could bore your friends with your vacation pictures before you got home. I mean, what a revolution. What are the ones that come to mind?
Maybe I would start with the digital camera again, because that change...
saved your marriage.
Yeah. I was first working, I started my career working on the Flash from the day zero of my career. And then in my lab, I used to have camera to test my controller. I used to do design the interface controller for all the media cards. And then I used to have a very early access to camera. Weekend, I take camera from my lab and go with my wife outside. And then I have the picture ahead than everybody else. And then everybody, my wife, oh, she felt very proud of it. And then that's like a personal life-changing. I have seen firsthand how it changed even a personal life in society. And then it's with me, many years later, like that time is like around probably 89, 90s, late 90s, and early 2000 is like digital camera everywhere.
Yeah, good. Well, keep that in mind, because when we talk about the future, I'm going to make you come up first on what the big application is ahead.
Yeah, so I was trying to think about how to answer that question, and another question came to mind. Which application hasn't been changed by Flash? Because I think it's very hard to find one that wasn't changed. And so, you look at music, you look at the way we store music, you look at cell phone, you look at your car, GPS, how many marriages that saved. But I think if I have to truly pick one, it's really a device that would not exist without Flash. And I'm not speaking about NAND Flash, which is the main today, but it's really basic Flash, right? Without NOR Flash, there wouldn't be any cell phone. We would be still connected to, again, maybe we would have wireless, but you couldn't store anything, you couldn't store your code, you couldn't do on-air patch and everything. So cell phones started with Flash, and they continue on, and now there are multimedia devices, etc. But to me, again, that's, if something has changed my life, is my cell phone, because now I know where my kids are, so.
You know where your kids are?
Well, I think the application tells me.
You know where their phone is.
I know where their phone is. That's right. Yeah, that's right. Yeah, that's right.
Doug.
Yeah, I would have to echo your comment, because the cell phone has been an incredible communication device, and it's sucked in everything else. In other words, the video camera, the audio player, the iPods, but that certainly wouldn't exist without flash memory, and obviously specifically like NAND flash memory. But I agree, it all started back in the day with NOR Flash, and NOR Flash evolved from EEPROMs. So UV squared EEPROMs were the key storage.
Would you happen to have one in there?
I actually do have it. Yeah, I do have some of the early EEPROMs. So I'm not sure if.
We've got
the
camera operator, gentleman is right there, and if you hold it steady, I think he can.
Let's see.
So kind of goodie coming out here.
Oh yeah, there we go. So, in the old days, people used to store. This was non-volatile memory from the 70s and 80s and early 90s. This was ultraviolet erasable. You had to actually erase it under ultraviolet light for like 15 minutes. And in fact, Flash.
Rotated about 45 degrees. There we go.
Okay, and so this was the predecessor to.
Camera's right there.
Oh, okay. So this is the predecessor to flash memory, because it's a single cell. You erase it all at once under ultraviolet light. Takes 15 minutes, and in fact, flash memory was unique because it was electrically erasable. Programmable read-only memory.
So I have a question about that I've wondered about for a couple of decades. If you had left that chip outside all afternoon, would it get enough UV?
I believe in a few hours it would. Yeah. Because it only took 15 minutes under an ultraviolet lamp.
Wow.
So people
chips that get sunburned.
Yes. People actually used to have to put black tape on top of these to prevent them from erasing.
Good, and I'll throw it out to the audience. Is there, since my panel has done such a terrible job of not covering a non-obvious revolutionary application, is there someone in the group who says, boy, there is something that is absolutely revolutionary that's not a camera and not a mobile phone? It was a total surprise. Show of hands. None yet. Well, keep thinking about it.
I will come to you if somebody knows can offer something.
Oh, good. Thank you. You are?
Lauren Shalinsky from Western Digital. So one of my early thoughts, and I don't know how revolutionary it really was, but it really gave Flash a place to start gaining ground, and that was the USB flash drive that replaced the floppy drive. So you remember floppy drives were a megabyte, I think, 1.5 megabytes in size? 1.44 megabytes.
Right,
And so the
1.44.
original USB flash drives, or even before that, there were various PCMCIA cards. There were things like that that tried to replace that. So that's kind of the first application that I think about.
That's a good one. I think about when the Mac came out and we got the smaller discs. I got this really nice leather case that you put them in, and I can't bring myself to get rid of the case, and I haven't used it in decades. So, Doug.
So you're mentioning PCMCIA cards. That really was the first application.
You got to aim it that
Make
way.
sure you show the face of it directly toward the camera so that
Okay.
we'll see
There you
the
go.
That was really the first application for NAND flash. It was expansion memory, so either RAM or non-volatile memory. So it had either NOR flash in it, which some PCMCIA cards had, and it had some of the first NAND flash. Actually, I have a prototype here that actually was one of the early ATA cards. I believe this is the one. Yeah, early ATA cards with NAND flash on it.
Do you want me to hold it for you while you talk about
Yeah.
it?
And that one has a Toshiba controller, but actually the other controller was an IBM controller.
Show me, get the one with the IBM controller. Is this too nerdy for everybody?
Is this the one?
Oh yeah.
That's it.
Yeah, that's the one.
Let me hold it up. So
Yeah.
one, it's an IBM controller card, and we'll see. This is testing the limits of current camera technology, which is still pretty low res. But what's really cool is up here you can see a bunch of patch wires. I mean, when's the last time somebody saw a wire on a circuit board?
You may want to show this, how floppy to.
Oh yeah.
And,
So
and that device you just held up, the beauty of that is you could plug it in and it would look exactly like an ATA disk drive. So, absolutely plug compatible. It did not require any special software drivers. Plug and play truly.
and you mentioned a floppy disk, and USB. And USB was an important enabler for accessing flash memory cards. Extremely important. Before that, it was floppy disks. And I'm not sure how many people know what this is.
Oh, yeah.
So this is a solid-state battery-operated reader that interfaced to a floppy disk drive, and it allowed us to read solid-state smart media through a floppy drive.
Right,
You
that
can
would
imagine
insert
how
all the way in
difficult-
and you'd pop it into your floppy slot.
Yes, you'd pop in the smart media into the floppy disk adapter, and then plug this into a floppy drive to actually read the data.
So, okay, I want to, and there's a point to all this, besides the fact that he's going to auction this all off on eBay and you all get the chance, is whenever a new technology comes, we all stand around and scratch our heads, or they all, I mean, they're the inventors, I'm just the moderator, and go, what the heck is this good for? And so you get this wild species radiation of different forms, and then it kind of settles down to the USB, stick and the like. What were some of the weird things that happened early on? And Doug, you've been here since the start, so you must know a couple.
Well, we had no customers at all for several years. So all flash memory prior to say 1980, or prior to 90s, was random access. So everyone knows about address bus and data bus. So random access memory. Even today, SRAMs and DRAMs are all random access memory. But flash was the first, and in fact, the first NAND flash that actually failed in the market was a 4 megabit device that did have a random access memory. It had an address bus and a data bus, just like a EEPROM did. But the 16 megabit NAND that came out in, say, 93 timeframe actually did have an indirect access. And that's actually a key thing because we were able to change the density without changing the footprint at all. So 16, 32, 64, 128. In fact, even today, the indirect interface still exists. So this indirect, I'm not sure why this indirect interface got created, but it's served NAND since 93.
Wild.
So those are Toshiba products. 92 for the 4
Yes,
megabit.
yes. These were Toshiba
93
products.
for the 16 megabyte.
Exactly.
Yeah,
So that means 5 years after the 1987 introduction of NAND by Fujio Masaoka was the actual first shipment of NAND.
Luca.
yeah, so you ask a question, what's the weirdest application? So I have again, they're not technology advanced, they're just a funny application that really never succeeded. So I'm from Italy, and we're all Catholic, and praying rosary is something that people do. And so at a certain point, I was working at a company, and they came to us and asked for automatic rosary prayer. So basically, rather than the priest having to say all of the Holy Mary and give the hint to the people there, they just put it on a USB drive on a small device, and people would put in their headphone, and so they would have, the hint to start the rosary alone. So that was one application that I found interesting. I don't know whether it really materialized, but I know there was a request. Another application, this is something that we did at SanDisk that never really materialized. So there wasn't streaming in TV, but we had this brilliant idea. You have a memory storage device, you have a computer. How do we connect the storage device, the USB storage device, to the computer? So we created this USB stick that you would plug in your computer. You would then download the movie on the USB stick, and then on the other side, you had like an HDMI or some sort of TV interface, and you plug it in, right? Very cumbersome process, et cetera, but we had it. It never really materialized, so that was kind of a funny application that really never. Right.
Well, again, it's the technology innovation process. Who remembers VCR players? Show of hands.
Yeah.
A couple people. And that you had, when they first arrived, you actually had to program the day and date.
Oh, yeah, that's right.
And no one did. Well, let's shift a little bit, thinking about these applications. There's a marvelous chronology of flash that I think, Brian, you put together that's on the site.
Yeah, it's on the wall, just outside the building.
Yes.
Yeah.
But it's also,
Just outside the room, I should say.
there's a thing called the web, and it's on the web, too.
That's right, we have a
Yeah, it's
PDF
really
up
cool.
there as well.
So we've all seen the chronology, many of you have lived through it. If you had to pick your favorite high points in the history of Flash.
Yeah, so I'm a little bit biased, right? So I come from SanDisk, right? So, and yesterday, it was truly mind-boggling to sit in the back with Eli, a legend in the industry, and have a chance to chat a little bit with him. But I'm a little bit biased, and I have a colleague from Kioxia over here, so I'm going to pick 3 milestones. So one of the milestones is something that we recognized yesterday, which is the first patent on MLC NAND flash by Eli, right? And I actually, for this, as I was preparing for this talk, I actually read it, and right there in the introduction, you can read, and it was 89. And by the way, this device with multi-level cell can be used to substitute hard disk drive back there in 89. And as a matter of fact, in 91, SanDisk actually built the first 20 megabyte SSD that were selling for $1,000. And I think it was mainly military and.
Wasn't that the one that was made as a plug and play for the IBM ThinkPad?
Yeah.
That was the first contract. They had a
That's right.
contract for $1,000.
20 megabyte, $1,000. So not something that people would buy normally. And then I have to pick also another milestone that is important. I think when one of the major players in the NAND industry was created, which was the joint venture between our friends at Toshiba and SanDisk. That was in 2000. And it basically created kind of one of the major innovator in the industry that really drove a lot of the invention. We brought in kind of the MLC, and Kioxia brought in the manufacturing powerhouse, and that joint venture is still going strong. So
Cool.
Those are my 3, but
I
know I'm biased.
Okay,
right?
Santosh, top that.
Let me put a little bit different color, and then I put a little bit marketing and then technology mixed together.
Okay, but we only have 30 minutes.
Yeah. In back 2005 time frame, very first time, the flash became cheaper than NAND. And then that changed like people, the way design the system. Like now flash is is the way to achieve something. It's like you want to improve performance, you want to lower cost. Is all flash enabled from that point of time, and then all system design has changed from there. And beside technology was there, but when it cost becomes then it becomes like
Getting the
real
pieces together.
together.
Classic technology innovation.
That's a tough one. No, actually,
There are many. That's
right,
the tough one.
Right, exactly. I think NAND is kind of an interesting, history because the NAND circuit architecture existed before NAND flash. I mean, it got famous because of NAND flash, but I heard about NAND circuit architecture back when we were making EEPROMs. Or not EEPROMs, mask ROMs. So mask ROMs were the original non-volatile memory, and to reduce the cell size, the NAND architecture connected cells in series. And that was a key thing in the late 80s. Flash, we use the word flash all the time, right? But flash came from a Toshiba paper for erasing electrically in bulk, and it was not a split cell, it was a single cell. So that was kind of a key innovation. Flash came from the feeling that you could, or the...
Oh, Shoji Arizumi.
Yeah.
And
Yes,
he
exactly.
looked at what Matsuoka was doing and go, Hotone, it's just like a flash camera.
Right, exactly, yeah.
I agree with you, and you stole my thunder, because if I had to pick a piece in the history, it would be when Shoji-san named it. Because, imagine, Flash is such a great marketing name. What if they had named it something like Dead Chicken? It just wouldn't have worked. And there are all those people out there who talk about Flash who have no idea what Flash actually is, but hey, it's Flash.
If I can bring a bit of personal story about NAND, right? Because right now everybody says, oh, NAND, who wouldn't use it? So
yeah, and if they had named it NAND, everybody would have thought they were talking about Mork and Mindy.
yeah, that's right. But so I think, it was back, as NAND was starting to pick places, and many companies in the industry were switching from NOR to NAND, right? And I was speaking to a technologist, right? And we were discussing about NAND, and he told me, look, NAND is a fundamentally defective device. Like, it is, when you look, because people were used to code storage and NOR technology. And NOR technology needed to be perfect. I remember the specs was, 1,000 cycles, read and write, error correction, bit error rate, because you can't, there's no error correction. You just boot it up, and the code has to be right. Because if one bit is wrong, it's just going to go, the processor won't boot up. NAND was fundamentally broken. Like, you look at the distribution, they were overlapping. And really, the brilliancy of the industry was to recognize that, put a solution to it, which, Eli said it yesterday, is a combination of cell, of course, system, error correction, and go from code storage to data storage. That was really the brilliance of the industry to realize that they really kicked off the NAND. And then, of course, cost reduction, et cetera, needed to enable it. But, I was speaking with a technology that say, you work on NAND, look at me and say, this is a crappy device.
Yeah, no, I think the term is crufty.
Yeah.
Or more simply put, the famous observation in Silicon Valley.
Yeah,
it's not a bug, it's a feature.
Yeah, that's right.
Just to add to that, I think the concept of doing like FTL, where you do mapping, where like you have something in front end, something in back end, that's enabled whole thing, like all the system, all the application, and then everything become perfect. Even though there is an imperfect back end, but front end make it things look perfect.
Good. So I'll bet Brian has one for us. Stop lurking. Get closer to them.
Yeah, so I have to go along with Luca. Indeed, I would say that a third of this conference is dedicated to the fact that Flash is imperfect.
Yes.
I mean, there's just a huge aspect of that. And, it's just that, so all that technology that creates that image of perfection is what, everything is built on. So it's like I said, probably at least a third of the infrastructure. I also had one other comment. Everybody was talking about what they thought their biggest thing with regard to Flash was. I think it was the Apple iMac introduced in August of 1998 that did not have a floppy, but it did have a USB connector. Within 6 months, actually probably within about 3 months, there were USB floppy drives, and within 6 months was a USB flash drive. And within 13 months, a formal standard for the interface to data storage on USB devices came out officially from the USB-IF. So to me, that 1 year period was
Refresh my memory.
huge.
Was the iMac the really ugly?
It was the one that looked like the bubble. It was
In
the first,
colors.
It was the one that Steve Jobs introduced that would kind of wipe out all the other Macs that
Right.
existed when he came into the company again. So
Cool.
to me, that's the biggie.
So for folks in the audience, if you want to join in on this, wave your hand. Do so he can see, because they literally put the lights in our eyes so we can't see. But if you want to add to this or anything else, just jump in. And it looks like we have.
Yeah, I got a couple of ones. Paul Sherman, formerly Western Digital and Goki US Lab, and I go back to Apple II days and playing with the 2708. Yeah, loved it. One thing is, I guess a sign of technology, when it changes, the society, it becomes a verb. Just like,
Can you
we
hold
all-
the mic a little closer? There you go.
we all Google things, and so what can, what here, became, made Flash become a verb? Isn't that BIOS? Computer BIOS, remember? When we want to flash the BIOS. And so that's, think about that. And also another area, and so I would say the BIOS technology became heavily dependent on Flash. And also, the FPGA, we used PALs and GALs and glue logic, and Flash was very, very important to easily reload or change the code for FPGA stuff.
So with regard to flash the BIOS, I think that was actually a coincidence. So people would flash BIOS by writing, for example, if it was like an EEPROM or EEPROM, EEPROM. And then Flash became the medium, so you didn't actually have to literally flash it. So I think that's a coincidence, but it's an interesting coincidence.
Okay. So
Any other comments?
We've started with the softballs, but now that you're on stage and you can't escape, what are the big challenges short term with Flash? What's going to mess up the party or continue things going? Luca.
So I mean, I spoke a little bit about it yesterday, right? I think so if you look at the Flash industry, has been driven by continuous cost reduction, right? And your cost reduction enables new application. You can really map out the cost per bit and new application being created as a one-to-one correlation. And there is this, elasticity in terms of if you make, if you build cheaper bits, you're actually gonna create more application. You're gonna consume more bits than and still keep, the funding. So the fundamental problem, it's really an economic problem. As you scale up, you can look at the complexity of what we do in the NAND flash, and really, it's absolutely amazing what we do. Like, you count the number of memory holes is in the trillion for each wafer. You count the way the process alignment happens, day in, day out, over thousands and thousands and thousands and thousands of wafers. Side note, if in Yokkaichi, if you were to take all of the wafers that we produce in 1 year and piling them up on top of each other, and each wafer is very, very thin, it would go as high as Mount Kilimanjaro. So just to give the scale of how big things are. So
And that's how many wafers over what period?
it is over a year. The wafer,
1 year, 12 months.
Yeah, 12 months, yes. So we have a nice slide, I can send it to you. That
Why
shows-
Kilimanjaro?
It's just because it matches.
It does, it happens to match.
It happens to.
Okay, well, I want to ask you a question.
Yeah.
I see about the other, first of all, the gift cards that play the songs. I've taken them apart, but I've never paid attention. I assume that's NOR flash in them.
Probably. Yeah, those music cards and
Yeah,
stuff.
would that be
those
NOR
are-
flash?
Those are
'Cause, I
probably
mean,
NOR flash.
I sort of feel like NAND flash is getting way too much attention on this panel, and NOR flash, and think of all the happy children made from those gift cards, and the analogy that one of those gift cards, a friend explained to me, contains more computing power than the guidance computer on the original Apollo command module. And so that we truly live in a world of disposable computers. So back to the challenges. Doug,
I think like, I would say like one of the challenges is cost versus everything else. Now there's a balancing between, there's a like our end customer requires lower and lower cost, but everything else, you take it the performance, you can take the power, and you take the demand point of view. Is like how do you balance? And the demand point of view, say like there is a requirement for enterprise, the requirement for mobile, and that vary a lot. And then how do you this tuning? How do you balance? And then you have to manage reliability.
So how is Flash going to respond to that?
I think every vendor has little different tuning, and they carve
So
out
it's lots
their
of
own
little
needs,
steps rather than a
steps.
big.
Yeah,
data
it's
set,
little
right.
steps, and then try to see, go in this direction, what you can do optimally, go in this direction, what you can do, it will combine both.
So the challenge is in the
It's not that take one bigger step in one direction, it's all small steps in multiple directions to achieve the optimal gain you can
So we've given you a lot of time to think about this.
Yes.
No pressure.
No pressure. Well, I'm going to echo what our previous panelists have said. Basically, Flash is differentiating into many different forms. So SLC still exists, MLC still exists, TLC exists, QLC is up and coming, PLC is up and coming. So Flash is differentiating to fit the market needs because one size does not fit all anymore. And it's hard to optimize for every application. So as Santosh mentioned, we have different flavors of Flash just for TLC alone. So even within TLC, there's different variants. So that is the way Flash is addressing various market needs, various niches. It's either cost-driven or it's specific performance-driven. And we have to optimize Flash separately for those different applications.
Yeah, I want to go back a little bit to Brian said, right, the importance of the link between what the basic technology is and the kind of the complexity of it and the difficulty of it, and then the application. It's really filled in by a lot of the system level innovation that are happening that are able to customize the same fundamental NAND to different applications. That's really how you close some of the gap, and that's where a lot of innovation is coming forward, I believe.
So if you step back, Santosh?
It's just like one short comment. It is a race of making imperfect to perfect.
The race of making
Imperfect. It's like
Make it
imperfect. Like you have in hand, is like ultimately you want to have imperfect is fine, but make it perfect at maybe system level or something.
Right. Error correction,
Yeah,
everything
error
else is
correction, yeah.
necessary.
Fundamental cell, you can be
the race of
imperfect
making
is fine.
imperfect perfect.
Yeah.
So here's the question. The pace of innovation in Flash has been breathtaking. And of course, it's actually a requirement of this convention center that you're not allowed to hold a session without invoking Moore's Law at least once in every session. But we know there are phenomena that are moving faster than Moore's Law, like the Carlson curve of decoding the human genome. Something really interesting happened in 2007, and it's going to an asymptotic approach to zero. Has the historic innovation in Flash, would you say its pace has been the same as Moore's Law, or faster than Moore's Law, or slower?
Oh, so I have my own opinion on Moore's Law, which is I feel it's almost like an economic law, meaning the way innovation happens and ingenuity happens is kind of linked on how much resources there are working on it. I mean, I want to go back to my example, like 2D NAND, basically everyone predicted the failure of NAND, and all of a sudden 3D NAND came up. And it's not because of course there were people working on it, et cetera, but there was a fundamental economic motivation to continue to reduce the cost of NAND.
Well, and you know that Gordon Moore famously said, well, first of all, he said, I didn't name it after myself. And then the second thing he said, look, it's not a law. It's like a speed limit sign on a freeway. And when I had heard him say this once, he said many times, I looked at him, I said, you know, you live just off a Highway 280. And we all know that nobody on Highway 280 drives the speed limit. So,
We have a
Also-
comment over here, if we could.
Brian,
Yeah.
Hi, John Monroe, formerly Gartner for 25
tell
years.
us who you are.
John Monroe. I was formerly with Gartner for 25 years, studying all storage markets. I'm now on my own with Further Market Research, LLC. A bit of history that really was important to my mind is I remember Toshiba, back in the mid to late 90s, came up with a 1.8-inch drive. There were a couple of suppliers there. And it sold nothing. Then suddenly this application came along, known as the iPod,
Yeah.
right?
Yep.
And then, and the genius of that application was the ecosystem to have the songs. When it first came out, the marketing came up, said, 5,000 songs in your pocket. I said, who the hell wants 5,000 songs in their pocket? Maybe 100, but 5,000? Well, it turned out everybody wanted 5,000 songs in their pocket, or even more. And of course, that morphed into the cell phone, which is multifunction now. And I think, yeah, you know, the iPads and the iPods, pretty much, it is the cell phone. That is the application, and that's everything within it. And will continue to drive a lot more memory because they're going to have richer stuff in there, and flash will be absolutely crucial to driving the mobile phone market in the future. Another bit of history is when we tried to go back down to 1-inch drives for the emerging iPod, and actually Hitachi GST built the damn factory in Longdon Shenzhen factory just to do that. And Apple's forecasts were amazing, like 15 million, 20 million drives. Well, September 2005 came along. I said, just joking, we're going to use flash.
Well, there's another interesting story about that, and that's that Steve Jobs called Eli Harari to his office, and before the iPod was introduced, because he wanted flash. He knew about flash. And he said, okay, I want you to sell me flash at the same cost as a disk drive. And of course, Ellie was like, you know, thank you very much, but no bloody way, because there's like a 4-to-1 at least price differential. So, you know, it was an interesting entree, but something that was not possible. But it's an interesting story that Ellie told me about.
That's great. Well, I love the pocket part because there's a long history in technology of lying about pockets. It goes all the way back to Sony and their first transistor radio. They build this pocket size. You know the story?
Yeah.
And
With 6 transistors, remember?
yeah, and they didn't quite fit. And so it's very simple. Morita-san had special shirts made for his salesmen with oversized pockets. I'm sure you've never seen that happen in marketing before. Also, any other audience comments or questions in here? There's a hand over here.
Johnson Code from Marvell Semiconductor, or Marvell Technology now it's called. I want to echo what Luca mentioned about the how broken is the NAND technology, how imperfect, and you look at it and say, oh, this technology sucks. But I just reminded me another great example is the compact disc. I think it was invented like 1980. And it was co-invented by Philips and Sony. And I remember I was once a Sony employee, so I read a lot about the history. And Sony said, oh, without our error correction technology, there won't be compact disc. And I just looked up, the compact disc error correction rate is, you need 1 bit for every 4 bits. Error correction, that's 25% overhead. So that reminds me of a technology.
you don't need the perfect technology. You should pursue whatever is practical, and any perfection is probably not the right way for technology to pursue.
Well, with regard to that overhead, one of the key things is they wanted to make sure that CDs could be scratched and still play. So indeed, that's very much a part of that, because they knew they'd be kicked around and stuff like that. So indeed, there was about that 25%. But that was, so it's about a 10-to-1 with the Reed-Solomon code that they used.
Cool. So we have about 5 minutes left, and I'm not going to let you off the hook without talking about the future. What are, and it's an impossible question, I admit, but I expect an answer. What are going to be the surprise applications going ahead?
The surprise applications,
Yeah.
I think it's going to be AI at some point. I mean, we expect things to be more computerized and more automatic, and the era of, in the next 50 years, I think we are going to have autonomous robots at some point. I mean, that will be something that will be enabled by vast, vast amounts of programmable non-volatile memory. Machine learning, it's coming.
I would say like just same things, like summarize like an autonomous machine that's come to car, like a robot military. Then you have like a robotic house help. Then comes to metaverse, and then you have AR, VR, where you can immerse. All this will be
So
enabled.
we got AI, and you mentioned VR.
Yeah. And smart machines.
And how does Flash play in all of that?
I think this all enabled by edge computing, and edge computing, the Flash will play a very dominant role in enabling those edge computing.
I'm seeing a skeptical look on Lucas.
No, I'm not skeptical. No, I think, it's hard to be very specific about applications that are happening, 20, 30 years ago. But I think I'm going to go back to what I said at the beginning. I think it's going to be hard in 30 years from today to get a device in your hand that does not have flash. Or actually, I want to be a little bit careful. It is flash technology. It might be NAND. It might be something else. I think the technology in 25 years will evolve. I think we'll find a way to continue more slow, as you said, because as long as there is some money to be made, there's going to be people working on it. There's going to be technology that are going to be used. And I also, we don't want to forget a little bit kind of the ultimate purpose of what we are here for, right? So I think as an industry, we are here to solve some of the problems that we have. So, if you ask me, I don't have an application, but I like to see headlines in 20 years from today. They say, cancer drug found thanks to flash technology. That's what I like to see. That's really what kind of motivates me to be in the industry and helping, because flash will be in this compute system. It will allow us to do super fancy calculation, build drugs that could be there, solve climate change. That's what I want to think about.
And that's a perfect lead-in.
And to add to this, whatever we are able to articulate today, that may be less than 50%. 50% we don't know. New application would come up. Next generation would come up something else. We don't know yet.
Sure, it makes sense. So,
If I can make a comment too?
Oh, sure,
Yeah,
Brian.
let's see, with regard to the AI part, there was a book that was co-written by two professors from the University of Ferrara in Italy, and they gave a talk yesterday morning. I was expecting it to be about machine learning being aided, machine learning applications by way of Flash. Turns out it was Flash being aided by machine learning in the actual management of the Flash itself. Yeah. So I think that's an example of how machine learning and AI can help the medium itself and also expand the possibilities for very imperfect media to actually be usable still.
Cool. So last question, and we're into transparency here. So I asked these gentlemen a question in advance to think about, and the question was, where will the world of Flash be in 2039? And instead of 35 years, we went to 17.5 years to make it easy. So,
oh yeah, of course.
Where will it be? 2039. These are the last words as we head out.
Well, you know, I think I was just came off, and I was on a DeLorean car driven by Doc Brown, and then he gave me a newspaper.
Yep.
And it says, you know, February 4th, 2039, NAND flash technologies just reached the milestone of 1,500 layers, super fast technology that is going to enable, you know, calculation to solve the biggest problem that the world has found.
Perfect. And it's running the Mr. Fusion drive on the DeLorean.
That's right.
Santos.
By the way, that machine is powered by flash as well. So that's time machine.
Okay.
See, we are here today after 3.5 decades, and you can see each decade is like a flash enablement role becoming bigger and bigger. And I see next 1.5 decade would be same thing. It will be more application and will be enabled by flash, and flash going to do is a multi-prong, is like going vertical, going horizontal, going logical, and going multiple bits, and then people like it's not only the fundamental cell, but the system is going to make it perfect, and then is going to go in more and more, and then I see it's like a very bright future.
Nice. Yep. Last word, Doug. No pressure.
Well, I don't want to say the Terminator is coming, but that is always a possibility. But I do believe that, you know, flash densities are going to be 100x, maybe 1,000x more dense than they are today. I believe the material system will actually change at some point, because physics is physics. Our current understanding of how MOSFET transistors work and stuff is based on things that we learned in the last 20 or 30 years, but things are going to change. If you look at material systems, silicon carbide, gallium nitride, quantum wells, I believe we are going to find a way to store charge efficiently in smaller and smaller regions by modifying the material system, and that is only at the beginning. I mean, gallium arsenide has existed for how long, and it never really took off, but LEDs, white light LEDs, blue LEDs have miraculously became available and well understood, so physics will change to make flash continue its progression. So Moore's law is not going to be dead for flash.
And my wish is that all those things will come true, and above all, picking up on the comment earlier on, let's hope and be sure that NAND remains a fundamentally defective product. Yeah. Thank you, gentlemen. Good. So I declare this session over. Brian, do you have a closing comment or anything?
No, but I appreciate your final comment. That's great. Keeps people employed.
Good. Great. So let's hop off stage, and I think people may have questions. So if you want to walk down that way, that might be a better move.
Oh, okay. Sure.